What's up, Algebra 2? Here we are with the first lesson of Unit 7, Graphing Exponential Equations. Okay, here's our base equation, our base function for exponential equations. It's called an exponential equation because the x is in the exponent. So we're going to have some base number to an exponent. It's going to be considered or look like exponential growth if that base number is bigger than 1. So like 2, 3, 4 to a power, and we'll always follow this pattern. And for x is negative 1, negative exponents just flip the base, so it'll be 1 over your base number to the first power. Anything to the 0 power is always 1, and then anything to the first power is itself. So those are going to be our 3 anchor points. And those are going to be the 3 main points that we're looking for as we go through this lesson. You can add more if you need to. Usually we go like 2 comma b squared. That can be helpful. Domain, you can see we go left forever and right forever. So domain, this is a nice one for us. Should always be all real numbers. And range, our y values are always above that line. Y's are greater than 0. Even if I go to like the negative 100th power, it's just going to be an itty-bitty decimal. It's never going to go negative. The only way it goes negative is if we have a negative number or a negative multiplier in the front, which then would flip it upside down. Exponential decay is when we have a b or a base number that's between 0 and 1. Like a half is the most common one to think of it. So negative 1, okay, if we go 1 or a half to the negative 1 power, you're going to flip that. 1 divided by a half is actually going to be 2. So then that's why the negative side is up and the positive side is down. If I do a half to like the 10th power, it's going to be a really small decimal. And again, our domain is all real numbers, and our range is greater than 0. Same old shifting rules that we always have. Okay, if it's up here with x, it's opposite. So minus goes to the right and plus goes to the left. If it's a big number at the end by itself, that's going to be your vertical change. Up goes down, up plus goes up, minus goes down. And numbers in the front are your multipliers, your stretch, your flip. Okay? So just thinking about 2 to the x. Okay? And you can use your calculator to type these in. 2 to the negative 2 would be 1/4. 2 to the negative 1 is 1/2. Anything to the 0 power is 1. 2 to the first power is 2. And 2 to the second power is 4. It might have been easier for us to do those 3. And then do the negatives, because the negatives should just be the reciprocals of their positives. So 2 to the first was 2. 2 to the negative first would be 1 over 2. 2 squared is 4. 2 to the negative 2 would be 1 over 4. Just showing you those. Okay? So, again, we're going to copy some of these over here. The negative 1 is going to be 1 over our b number. So negative 1, comma, 1 over 2. 0, comma, 1. 1, comma, 2. So negative 1, comma, a half, so barely up there. 0, comma, 1, and 1, comma, 2. Now, a lot of these are going to be pretty close together. So if you want to go another one, 2 comma b squared, we'd have 2 comma 2 squared is 4. If you want to add another one. And then we can really see the shape happening. Remember that we don't cross this right now, so we're going to have a horizontal asymptote there. And we're flat and then going up and to the right. Okay, for a half, reverse, let's do the bottom half here, how we thought about last time, it'd be easier. Anything to the 0 power is 1. Half to the first power is a half. Okay, half to the second power, half times a half is a fourth. So if we do the negatives, they should be the matchers, but flipped. So half to the negative 1 would be the flip. It's going to be 2 over 1. Half to the negative 2 is going to be the flip. It's going to be 4 over 1. So again, these are our three main points that we want to have, our anchor points. Negative 1, comma 1 over b. So 1 over a half. 1 divided by a half should be negative 1, comma 2. 0, comma 1. 1, comma b. 1, comma a half. Okay, we didn't have any left and right or any up and downs, so we should still have our horizontal asymptote there. Negative 1, comma 2, 0, comma 1, 1, comma a half. Okay? If you want to go another one, sometimes I like to just go 2, comma b squared, just to have another one, because those three together, it's kind of tough to tell. As you get better at these, you'll remember that a little itty-bitty fraction should be getting smaller to the right. So 1/2 squared should be 1/4. Like, oh yeah, this is going to be the really itty-bitty on the right-hand side. Okay, another thing we should be doing is if it's not a perfect point, we should be labeling those on the graph. Okay? Let's get into some left, right, up, downs. We'll do maybe 2 problems on the back. Okay, so we have negative 1, comma 1 over b, 0, 1, and 1b. So our b is 2. Our b is 2. So we have negative 1, comma 1 over 2, 0, 1, and 1, comma 2. Okay, the first thing we need to look for is a multiplier. Multipliers are going to go to the y numbers, and we have to do that step first right away. We don't have any multipliers. Okay, so we get to move on to the left, right, up, downs. Okay, we have minus 2, which is going to go 2 to the right. And we have plus 1, which is going to go 1 up. So first off, that plus 1, that 1 up is going to move my asymptote line to 1. Okay? And then next, down here, I want to write something like this, plus 2, comma, plus 1. And I'm going to do that to all of my points. So I'm going to add 2 to all the x's. Now, different people like to do things different ways. Some people like to go through and do all the x's first, and then all the y coordinates. And some people like to do each point on its own. Up to you. So negative 1 plus 2 is 1. 1/2 plus 1 is going to be 1.5. 0 plus 2 is 2. 1 plus 1 is 2. 1 plus 2 will have 3. And 2 plus 1 is also 3. So we have 1, comma, 1.5, right above the line, 2, comma, 2, and 3, comma, 1, 2, 3. Alright? So we can use that line to see we should be going up and away from it. And there's our graph. Let's see one with a multiplier. Let's see one with a multiplier. Okay, let's come down here. So we still have negative 1, comma 1 over b, 0, comma 1, and 1, comma b. Alright, so we have negative 1, comma 1 over 2, 0, comma 1, 1, comma 2. Okay, we have a multiplier, so we need to do that first, and that goes to the y's. Apologies here, we're going to get some background noise with the kids coming in. So we're going to go negative 3 times all the y's. So negative 1 comma negative 3 halves, 0 comma negative 3, and 1 comma negative 6. Okay, that multiplier goes to all the y's. Now we're going to go through and do our x and y add subtract ones. So it's going to be minus 1 to the x and plus 5 to the y's. So that's going to be negative 2. Okay, negative 1.5 plus 5, that's going to be 3.5. Negative 1 comma 2. 1 minus 1 is 0, and then negative 1. Okay? Also remember that plus 5 is going to move our asymptote line up. 1, 2, 3, 4, 5. Okay, and we had a negative, so we're expecting it to be on the bottom side. So negative 2, comma 1, 2, 3.5. Negative 1, 1, 2, and 0, comma negative 1. Okay? So we should have something like this. Okay? And there our domain would be all real numbers, and our range would be y's are less than 5. Alright, folks, hopefully that's helpful. Stop in and ask questions if you needed to. And we'll see you guys next time. Good luck.